of cosines allows us to solve things that law of sines does not. So when you're looking up here at these two situations, look at the first one right here. Is there any way you can use law of sines to solve this? You've got two sides. That means you should get an angle across from that side. Do we have angle A across from 7? No. No. Do we have angle C across from 5? No. We only have angle B, which is across from 1 we don't have. So there's no way to use law of sines in this problem to solve it. Same thing with this one. When you have side, 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 you look at the situation. Do I have an angle that I can compare with the side? I need at least one of the angles. Okay? So these are two situations in which you would want to use something different. And they use what's called the law of cosines. And the law of cosines, I've written down here. It's ugly. You want to use it as a last resort situation because you can see it's not a nice one to try to figure out. So the law of cosines, and I will write it on the test when you have to do it, so you don't have to worry about memorizing it, but you have to understand what it does. You have to go to the side across from the angle or the angle across from the side you're trying to find. So if I'm trying to find side A or angle A, side A squared is going to equal, listen up guys, the other two sides squared, so B squared plus C squared minus 2 times the two sides that are over here that form that angle, BC, and then cosine of angle A, which angle A is across from side A. You'll notice these two always correspond. Angle A, side A. Down here, the other one is the exact same formula, only they're trying to find side B or work with angle B. So the B and the B are across from each other. Then the other two sides come in here at A squared plus C squared, and then minus 2 AC cosine of B. If I wanted to do side C or angle C, I would put those at the two ends. The other two sides squared minus 2 times AB. So this is the law of cosines, and we're going to use it to solve these two situations. Questions so far? Okay. The first situation. All right, so it looks just like the one I have drawn down there. If you have 5 and 7 and 130 and you want to find the side across from 130, you want to find side B, okay? Then you can say, this is the side we want to find, so you're going to go up and use the side, the one with the B there. So you're going to go B squared equals the other two sides squared, so 5 squared plus 7 squared, minus 2 times the 5 and the 7, and then the cosine of the angle between them, or the angle that is across from side B, the cosine of 130 degrees. Okay, so it's just that you use your calculator. The numbers are kind of big. 5 squared is 25, 7 squared is 49, minus 70, take the cosine of 130, and you get negative. Now, you've got to be really careful in here because you're going to have a double negative, which is going to make what? A positive. Ryan, are you writing this down?
Yep.
It's now on the recorder, so I hope so. Okay. B squared is going to equal, it's going to be on the recorder too, Britt, that you're bugging him, so quit.
Yes.
Okay. 74 is 25 plus 49. The double negative here is going to make a plus 44.95. That's 118.995. Leave all that number in your calculator as you're working through. Take the square root of both sides, and you're going to get that side B can be 10.9. Once you know side B, you can now find angle A or angle B by going to law of sines, okay? When you go to law of sines, if you need to solve the triangle, always find the smallest angle next. So what would be the smallest angle next?
C.
Angle C. So if you were to go on and solve the rest of them, because angle C is across from the smallest side, so it would be the smallest angle. You always want to find the smallest angle next, because when you go to law of sines, you don't want to have to worry about that ambiguous case, and finding the smallest angle will allow you to do that. Okay, let's look at the last example, which is the other one that we did right here, which would be the law, or the side, side, side. Okay, we'll kind of go like this. Okay, the side, side, side here is solving the other situation that we had that I put up there that you can't use the law of sines on. And we're going to find, I don't care which one, I'm just going to put angle, it would have been angle B or theta right there. Okay, which side is across from theta? 12. So that's the one you're going to start with, the one that's across from the angle you want to find. So we're going to start with the 12 squared over on this side. So you'll see that we've got 12 squared.
How do you know the best angle you can find?
I just said if I give you this situation. You didn't know. I just say if I said find theta, then you would know to go to the one across from theta. And so you're going to go 12 squared equals 10 squared plus 5 squared minus 2 times the 10 and the 5, the cosine of the angle that you want to find. Okay? So we're going to work through this. This time we're finding an angle. So we're going to have to use the inverse cosine in the end. So 12 squared is 144. 10 squared is 100. 5 squared is 25. And we get 200 we get 50 times 2 or 100 in here. Or 20 times 5, whichever way you want to look at it. The biggest mistake kids make is they want to take the 125 and subtract 100. You cannot do that. You've got to move the 125 to the other side and leave the 100 with the cosine because you have to follow the orders of operation. So we're going to get 19 equals negative 100 cosine, and then we're going to divide by 100, and you're going to get negative 0.19 equals cosine theta, and now we're going to hit inverse cosine. So when I hit inverse cosine, I get theta going to be 100 and 100.9527 degrees. Now that's all the way over here at 101 degrees. Remember, cosine is positive in quadrant 2 and 3. Negative in quadrant 2 and 3. So if I was going to actually find the other one for cosine, it would come down here and be a 259 degree angle. But this quadrant 3 angle is always too big to land in a triangle, so you really aren't ever going to need to use that second angle for cosine. So the nice thing about using law of cosines is you never have the ambiguous case. Double angles will never come in with cosine. They always come in with just sine. Okay, so there's no ambiguous case for cosines because the angles land down, the dual angles will land down in quadrants 3 and 4, and they're not going to be small enough to fit in a triangle. So nice enough with law of cosines, you only have to check the one case. There are 2 situations in which you need to use law of cosines, and you need to just remember that, whoops, it fell down, that you always need to use law of cosines anytime you have side angle side or side side side. You'll notice up here we had side angle side, and here we had side side side. Those 2 situations are the time you're going to use law of cosines. Any other case, you're going to want to go to, law of sines. So you don't want to use cosines unless you have to. All right, how'd you guys feel about those? Okay? All right.